Hi everyone, my name is Gaurav Gupta. I'm a lecturer in Department of Computing, Macquarie University, and here I'm going to talk about what's the right approach to coding. So coding done right. A lot of you are influenced by what you see in the media, whether it's social networks or whether it's movies or video games, etc., on what coding is like. So let's get that misconception out of the way first. So a lot of people visualize coders to be the guy on the left who's Ryan Gosling, but actual coders look like the guy on the right who's James Gosling, who's the designer of Java programming language. Similarly, very few programmers look like the girl on the left, that's Trinity from Matrix. In reality, on the right side you have Margaret Hamilton, who's the principal software designer of the NASA's Apollo program, or was. A lot of code in production is not flashy. A lot of code in production and a good design is very simple, and it's done usually with whiteboards and rather boring pen and paper. Which brings us to the next point. What is it that you need for programming? You don't need a massive glamorous rig. All you need is pen and paper, and most importantly, caffeine. So, one of the most important things to realize is what's real versus what's not. So in that regards, there are lots of pre-notions that affect how you jump into programming, and that's why it's important to start coding or enter programming with a very fresh and positive mindset. Sometimes it will be challenging, sometimes it's going to be hard, but when you do things in a systematic manner, sincerely, the output is very rewarding. I'd also like to add that there's no one kind of programming. There are lots of different kinds of programmings or coding. For example, you can have graphical coding, you can have network programming, you can have database programming, you can have algorithmic, numerical, or even financial programming. So take a look for yourself on what excites you, and if something is not what you feel it should be like, then you can always move to the next one. Now, one of the most important parts of problem solving is actually understanding the problem. It might sound a bit of a cliched statement, but understanding the problem is half the battle. And that's where half the battle can be lost or half the battle can be won. If you understand a problem clearly, the next stages of problem solving will become that much easier, and vice versa. If you do not understand the problem clearly, even if you end up solving the problem, the solution will probably be half-baked and, in most cases, buggy. So, a significant proportion of mistakes occur in this stage of problem solving. So, one of the most important things in this talk is how do you understand a problem satisfactorily? Here, we're going to take an example of a client's requirement, and all that the client requires is to have that red circle go around the bigger circle, or the red dot go around the bigger circle. That's all. So a client comes to you and says, hey, these are my requirements and I'm going to pay you $1,000, $2,000, whatever, for you to write a program that achieves that. Let's run this animation. And you can see that the red circle is traveling on the circumference of the bigger circle in a clockwise fashion. Take a couple of looks or have a couple of goes at this video and try and understand the different aspects of this requirement. What are the three different aspects that we see? You can see that we need to draw the big circle over which the dot will be traveling. It can be 100 pixels in diameter, it can be 200 pixels, it can be 300 pixels, whatever. So we have to keep that in mind, that the diameter of the circle can be varied. Similarly, the dot, currently it's red, but similarly it could be blue, green, magenta, ochre yellow, any color. Also, it could be 10 pixels in diameter or 20 or 30. But obviously the diameter of the bigger circle to the diameter of the smaller circle must be reasonable. And the third and the most important aspect of this problem is, of course, the motion. The dot's moving in a clockwise order and it's moving fairly slowly. But it could also move in anti-clockwise fashion, and it could move either slower or faster on the bigger path. So these are the different things that you have to take care of when you eventually program this design. The most important thing, however, is how do I find the location where the red dot should be placed? And this is where the importance of background knowledge comes into picture. So how do we determine where should the point be on a circle? And this simple flowchart explains how we're going to achieve this. In middle school, you guys will study trigonometry. When you write this program, you need to check, have you studied trigonometry? If you have, do you remember any of it? And if you do, fantastic. If you don't remember the relevant parts of the math, or you've never studied that part of the math, then you need to figure out whether you can work it out after some sincere effort. And even if you can't do that, then you need to search. So, what is our problem statement? What we need to find out is, given a circle that has the center as a point Cx, Cy, and a given point x, y that has to be calculated, given that the radius of the circle is, let's say, r, and the angle at which this point lies relative to this horizontal line is theta. I'm just going to complete this right angle triangle, and what we are saying is this angle is theta. So the known values are Cx, Cy, the radius, and theta, and the values that we need to calculate are x and y. The only prerequisite knowledge that we need to have for this is the fact that the ratio of base to hypotenuse is cos theta, and the ratio of perpendicular to hypotenuse is sin theta. In our case, we know that the hypotenuse is the radius. So I'm just going to plug those values. R. What are the base and perpendiculars? Now, if I complete the coordinate system and say this is the origin 0, 0, then center being at Cx means that this intercept on x-axis is Cx, while our point x and y is here, which means this intercept is x, which gives us the value of base as x take away Cx. Similarly, the y-intercepts for the center is Cy, and the y-intercept for the point in consideration is y, giving us the value of the perpendicular as y take away Cy. Plugging those values in here, we can see that it's x take away Cx over r is cos theta, and y take away cy over r is sin theta. We can solve for x and y, and we get x is center x plus r cos theta, and y is center y plus r sin theta. And those are the values we are going to use in our program that we'll show you in a little while. So that's it. Given the known variables, we now have the values for x and y for changing values of the angle. So as the angle changes, we'll continuously calculate the new values for x and y over the circle. Just for the sake of comprehensiveness, in case we cannot work that out on our own and we need to search, it's very important to search the right phrases and for the right terms. Where do you search? You can search across literature, you can ask your contacts, and of course there's the internet. What you search for is equally important. So here I have three ways in which I'm searching for what we needed here, and you'll notice that the first two searches give you inaccurate results, while the last one gives you very much relevant information, which is point on circle. Next is what I feel is the easiest part, where we've done all our hard work, where we've done our design, and we're going to do the implementation in a language called processing. Now, processing, you can see, is a language which is usually used for visualization and also teaching programming to university students and even school students. I've added a couple of links for processing over here. That's their website. If you need any help with any of their functions, then the processing reference is there. And I've got two cheat sheets provided here, and let's take a quick look at one of them. So you can see that processing has a specific structure. It has two main functions: setup, which runs at the beginning, and draw, that runs repeatedly. It has lots of shapes, it has some conditions, etc., but we're not going to use them. So let's take a look at the program which implements our design. I want to explain every statement of this program as we go along. So here we have a program that I've written in processing to achieve the design that we just created. I'll explain every line as we go along. On line number 1, we have float, radius, diameter, and angle. Radius and diameter are for the radius and diameter of the big circle. Of course, we don't need both of them. We can just have the radius, but it helps to have individual variables serving their own purpose. Angle is a variable that will record the angle at which the traveling point is, and that's the value that will change throughout the program. Processing has two parts: setup and draw. Setup is something that executes only once. So whatever's in the curly brackets inside setup executes once at the beginning of the program. What we are doing is we are setting up the canvas to be of size 600 by 400, which is 600 pixels wide, 400 pixels high. Once we have that value, processing will record the value 600 in variable width and 400 in a variable height. We calculate the radius as height over 4, and once we know the radius, diameter is twice the radius. As I said earlier, you don't need both the variables. You're okay with one of them, but for the sake of self-documentation, this is helpful. Now, draw is a function that executes repeatedly. So whatever I have inside the curly brackets of draw executes over and over again. What are we doing? We are erasing the background every time because we want to erase the previous red dot. We are setting up the brush attributes, the color of the brush, and the size of the brush, etc. And we are saying I don't want to fill the big circle with any color so that it's transparent inside. Once we're done with that, we can draw the big circle using the circle function. Fairly straightforward function. When I right click and say find in reference, you can see that processing has an explanation to what that function does and says that the syntax is x, y, and extent, which is the diameter. So here the circle is centered at the middle or the center of the screen, which is width over 2, height over 2, which is 300, 200 for our program, and its diameter is whatever value is inside this variable. Now all that design pays off here, where we calculate the value of the point x, y. So given the center, width over 2, height over 2, the radius is radius, and the angle, theta, is angle, we can calculate x and y by saying x is half the width plus radius times cos angle, y is height over 2 plus radius times sine angle. And then draw that red dot on the screen. If we just do this but don't change the angle, our red circle, as you can see, is located at angle 0 and it never changes, so it stays there over and over again. But if you want to make the red circle move, we need to change the angle. So here, let's say I increase the angle. Increasing the angle will make the circle move clockwise. So you can see that it's at angle 0, then as it becomes more and more positive, it will go around. Once it goes beyond 2 pi, don't worry about that too much, it will repeat the same cycle again. So the angles are in a cycle of 2 times pi. If I want the circle to move anti-clockwise, I can simply change the direction to negative. Now that I do that, the circle is moving anti-clockwise. Lots of other changes can be made to the program. If I change the radius to height over 3, you can see that the big circle is bigger. I can change the diameter of the dot, and now the dot is bigger. I can also change the color of the dot to 00255, so no red, no green, and full blue, which means that it will be a blue dot on the circle. So as I said earlier, it's important to understand the problem completely and be aware of the things that can change during the course of your program. Alright everyone, so that's all from me. I hope you have an enjoyable and satisfying programming experience in the future. These are some of our social network handles. Our website is mq.edu.au and our Twitter, Instagram and Facebook handles are shown here as well.